ionizable molecule with a polarizability alpha sits at x naught 0 near a uniformly charged ball plus q located at x naught y naught. Calculate the induced dipole moment. So, considering that we have a positive q up here, the dipole moment is going to cause the electrons to move to this side, the upper side of the neutral ball, and the bottom half is going to be left positive. So that means that our p hat is going to be negative 1 in the j direction. Additionally, we know that P is equal to alpha E. So we can assume then that the magnitude of P is equal to alpha the magnitude of E. As a result, because it's just point charges, we can use kq over r squared, or q over 4 pi epsilon naught, and the distance between the two of them, since they're just vertical, is y naught. So we're going to just say y naught squared, since they're both at x naught. So as a result, P is equal to alpha times RE, so alpha Q over 4 pi epsilon naught y naught squared. And again, we said that it was in the negative 1 j hat direction, so this would end up being our P. Number 2, calculate the force on the dipole. So we know that when we have parallel dipoles, E is equal to 2pk over r cubed. R is still going to stay as y naught. So we'll take our p, we'll multiply it by 2, multiply it by k, and then divide it by y naught to the third. So basically the only differences between this and p, we have the 2 here. Oh, and then additionally, when you get the force, you multiply the electric field by q. So we have 2, we have the q squared, we have our 4 pi epsilon naught squared, and then we also have y naught to the fifth, because y naught squared times y naught to the third is y naught to the fifth. It's still going to be in the negative j hat direction. So multiply all those together. Essentially, you have F is equal to 2k q squared, where we calculated qs to be p over y naught squared. We already knew p. For 3, find the force on the positive uniformly charged ball. That's just going to be the same because of Newton's third law, which is equal and opposite forces. Yes. So we're just going to have the same magnitude, but it's going to be in the positive j hat direction. Finally, again, because of the equal and opposite forces, in order to balance it, we would just put it at an equal and opposite direction. So an equal direction could also be over here or over here, but we need it to be specifically opposite. If it was not equal, it could be here, it would still not work. We need it to be an equal and opposite direction. So it's going to have the same magnitude because it has the same alpha, same q value, etc. It's just going to be y naught below the neutral ball, which is going to be at x naught